Hello to all. I'm Carol Murphy, Global Product Marketing for Voltage Secure Data. Our speaker today is Sid Dutta, Senior Data Security Products Executive here at Micro Focus. We're very excited to have Sid as our speaker on our topic, how to protect your data as you migrate to multi-cloud environments. As you'll see from his biography, Sid is currently responsible for driving product strategy and roadmap for Voltage Secure Data, focusing on cloud integrations, big data, and secure data as a service. Sid comes from the enterprise side, and he has led cybersecurity, risk remediation programs and services globally at various large corporations in the financial services sector for a number of years. Most recently, Sid was Vice President and Global Head of Data Protection and Applied Cryptography at WorldPay. And prior to that, he was Director of Cryptographic Utilities and Services at American Express, and he has held a number of IT leadership roles there before he moved into cybersecurity. Sid, welcome.
Thank you, Carol.
To get started, we know companies are moving more and more data into the cloud, and with that, more high-value, regulated, sensitive data. But I think most importantly, it's not just moving data into the cloud, it's that many enterprises are multi-cloud. It's moving data into multiple clouds, and that presents a challenge. So my question is, to what extent can we rely on the cloud service providers for data protection?
That's a great question and a loaded question. So before we kind of get into some of the specifics of what the cloud services providers offer, for data security, and of course in the context of how enterprises can manage a multi-cloud environment and have an enterprise data security solution to protect their data across multiple clouds and on-prem as well, let's take a look into what the cloud services providers essentially have in terms of what they call a shared responsibility model, when it comes to security. Now, I've used AWS as a reference model, but the same model applies to the other cloud providers as well, whether it's Azure or Google. So as you can see, they have very clearly articulated what security of the cloud means or entails versus what security in the cloud means, and who is responsible for which piece of this shared responsibility model. And it's very clear in this diagram that the customer is responsible for security in the cloud, which means that customer data, or the data that is actually stored on these cloud services, the customer is responsible to make sure they are protected. Now, in the multi-cloud context, obviously, they need to implement solutions that are standard across multiple clouds and on-prem as well. So let's get into a little bit of the specifics of how the cloud services providers are individually offering different capabilities for data security, whether it's crypto, key management, so on and so forth. Now, I think the cloud services providers have done a good job in catching up with the demands and needs of the industry and the customers and the concerns that traditionally existed with cloud adoption and migrating workloads and data into the cloud. So even though it was not something that was built in or built from the ground up, it was more of an afterthought and a bolted in capability. But at least now enterprises have the option to look at these services, from a crypto and key management perspective. So each of these major cloud services providers, they offer key management services, or KMS as they call it, and they also have Cloud HSM, which are offering additional capabilities and addressing some of the needs that customers may have regarding FIPS 140-2 compliance, or any other industry standard or regulatory compliance. But key management services in general, they offer APIs for applications to either encrypt small data like secrets or even keys, and they are also kind of a key store. Now, they operate in the model what they call as a master key and a working key model. The master key, typically known as a CMK or customer managed key, is what stays inside the KMS, or in a lot of cases in the Cloud HSM, and that never leaves that infrastructure. However, The data encryption keys, which are used for doing bulk data encryption, those that actually leave outside of the KMS and may get generated out of the KMS in some cases, but in other cases, it may be generated locally. So the model that they have in terms of data encryption, what they call as envelope encryption, and it's a practice of encrypting a data with a data encryption key and encrypting that data encryption key with another key, like a master key or a key encryption key or a CMK, and storing the encrypted data and the encrypted key together. So during decryption time, you would know which key was used to encrypt a particular data, and it would require that encrypted key to get decrypted inside the KMS, and then the plain text key can be retrieved, which would eventually decrypt the encrypted data. Sounds a little bit confusing, but it's really not. And of course, the challenges with that is every time you read or write a particular data and protect or access, there is a trip to the KMS that is required, which could essentially create some challenges, from an availability perspective, from a latency perspective. Now, Google also launched another service called DLP, which not only allows the applications and our customers to inspect and classify data, but it also allows to redact data. And redaction could mean masking, date shifting, even format preserving encryption. So that's one of the areas that they have actually done a little bit more than its competitors. The issues with all these capabilities is that you have a cloud service lock-in. What I mean by that, if you are in a multi-cloud environment, each of these services that these cloud providers offer individually are restricted within the perimeters of their own cloud boundaries. So you can't really use an AWS KMS or a Cloud HSM in Google Cloud or Azure, and vice versa. The other aspect is, since these were an afterthought and were built on top of their cloud infrastructure and cloud services, there is a lack of homogeneity in terms of availability of the same service across multiple regions. Also, the individual services that consume the key management and crypto capabilities, they don't integrate all the time. So there are some issues with compatibility across various services. There's lack of key management abstraction. Of course, the keys are managed at the application layer. Also, there are lack of encryption format choices and other data obfuscation options, like format preserving encryption only Google offers right now. But capabilities such as tokenization or partial encryption, these are not available. So it's very standard AES 256 in GCM mode that you would be doing encryption. And then, of course, as I talked about, these models where you have a dependency on calling an API to either decrypt your key so that you can encrypt or decrypt your data, or classify your data and encrypt it. Since you are dependent on the availability of these systems and services and the network between the applications and these systems, you may run into performance as well as availability issues. And then, of course, they have also enabled what the industry term is bring your own key and bring your own KMS in acknowledgement of the fact that there is a concern about cloud services providers hosting and managing keys, and particularly in the multi-cloud environment where enterprises don't have a total control when these keys are actually pushed into this cloud services.
Mm-hmm. Sid, I'm hearing a lot about BYOK and BYO KMS. Can you tell us what these are for and what they solve?
Absolutely. So bring your own key. This actually is a little dated term, and this was even before these cloud services providers started to offer these. We have had other cloud services or like SaaS type of services that exposed to bring your own key capability. And the whole notion of this is to address the concern that cloud services providers are hosting and managing my keys. So I need to have a capability for me to generate the keys myself and store those keys on the cloud services end and manage those keys. Now, there's obviously a lot of confusion in terms of how much access do the cloud services providers have for those keys that the customers are pushing in the bring your own key model, and how much of that concern from a security perspective and an ownership perspective is being addressed. But it definitely addresses a lot of the checkpoints and audit processes where enterprises can claim that, yeah, no, we manage the keys because we are using the bring your own key model. Now, in the case of bring your own KMS, this actually solves a little bit more in terms of where you don't leverage the cloud services own KMS, but you leverage something that is cloud agnostic. And in a multi-cloud environment, you bring that KMS service, whether it's hosted on-prem or as a managed service in a third-party data center, and then you cater to multiple clouds by exposing the keys at this cloud agnostic KMS for the applications to use. So if you're on AWS and Azure, and then you're interfacing with KMS that is outside of these cloud services providers' infrastructure, then it gives you a little bit of control on the key management, as well as you are able to cater to a multi-cloud scenario. However, in either of these cases, the keys are handed over to the cloud applications to get managed locally, and you lose that abstraction and control, because once the keys are delivered or retrieved by the applications and then they're stored locally, either stored on a properties file or in a file storage service, you don't have any control on how those keys are being protected and how they're being managed, so on and so forth, and who's got access to them.
Mm-hmm. So then what is our model? What does Voltage Secure Data offer?
Great question. So in the context of cloud data security, what I would call that our model is kind of more bring your own encryption, not just the keys, not just the KMS, but the entire stack. So regardless of whether you are in a hybrid model or in a multi-cloud environment, we allow our customers to basically take the entire encryption stack. Now, how we're doing this is in different models. I mean, you could still have Voltage Secure Data deployed on-premise. However, the clients could actually be in the cloud. The applications can have those clients embedded, or they can actually make REST API calls directly to the on-prem infrastructure. Or, they can actually implement or deploy Voltage solution in the cloud itself. So that kind of cuts down on any of the latency requirements and network availability requirements between the cloud and the on-prem data center. And you could deploy in any of the clouds, whether you're on AWS or on Azure, and have those systems be local to the applications calling them. Now, you may actually have a need to come back to the on-premise data center if you have an HSM, let's say, for key derivation, or you're leveraging Active Directory, which is on-premise, for key authorization. But we didn't really stop at this. We basically, expanded the capability for Voltage to be more cloud-like, that now Voltage services are available as microservices that can be containerized and deployed using Kubernetes. And now you can deploy Voltage as any other solution in the cloud. You can tie that back to your CI/CD pipelines and deploy it individually, each component, scale them individually, so on and so forth. And then, of course, there are other services like HSM as a service, which are hosted in the cloud, not on-prem, and we would integrate with those as well.
Great. Now, understanding the Voltage model better, what would you like people to take away from this? Could you summarize why this is a powerful solution to solve customer issues?
Absolutely. So Voltage is an enterprise-grade data security solution, has been addressing data security and privacy needs for our customers for a number of years. In the context of cloud data security, one of the biggest differentiators is that we are cloud agnostic. Regardless of whether you're hybrid or multi-cloud, whether you want to deploy it on premise and in one or more cloud or deployed as a virtual appliance or a containers microservices. So we support all that different models of implementation. And we offer a stateless key management solution, which is another market differentiator. We don't store keys. We don't store any token tables or vaults. So there's no PAN token mapping that could be essentially attacked. And we abstract key management and crypto operations from developers, which is a great differentiator. We offer client libraries, for local crypto operations, as well as REST interface, for remote operations. We support a range of crypto methods, FPE, format preserving encryption, format preserving hash, embedded format preserving encryption, partial encryption, standard AES 256 for structured and unstructured data, safe Unicode FPE. So these are some of the wide array of options available. And we support a lot of integrations with various cloud services as customers are migrating to the cloud and leveraging those cloud services natively.
Wow. That's great. Thank you, Sid. That was a great summary too. And now I think we're about out of time and ready for Q&A with our audience.
Well, thank you, Carol.